sources play an important role in shading. Light that strikes an object is partially absorbed and partially scattered. The amount reflected determines the color and brightness of the object. The reflected light is scattered in a manner that depends on the smoothness and the orientation of the surface. So we have studied all this. Light sources in the real world are difficult to model because we must integrate light coming from all points in the light source. For example, if we want to determine the light that strikes this point, we must integrate light coming from every point in this light source. To make things more difficult, because of the finite size of real-world light sources, we will get complex shadows. Parts that do not see the complete light source will be in the darkest inner circle called the umbra. Now parts that see the full light source will be in the brightest part, that is outside both circles. But parts that see the light source partially would be within this circle, where as you move from here to here, the light source will slowly vanish behind the object. This complicates real lighting further. In computer graphics, we define simple light sources, such as a point light source. It is modeled with a position P given in homogeneous coordinates, x, y, z position and 1 at the end, and an intensity I, which are the red, green, and blue components of the light that it emits. It illuminates equally in all directions, and we can apply an attenuation term I to diminish the intensity of light as we move away from the light source. The second type of light source is a spotlight, which is modeled with a cone with an apex P0, a direction IS, and a cone angle theta, and of course an intensity with RGB values of the light. The theta is the angle from the center to the edge of the cone. If theta is 180 degrees, this becomes a point light source, and again we can apply an attenuation term to diminish this light as we move away from the light source. So how do we perform this light attenuation? For a point light source, light intensity decreases with the square of the distance. So this is what happens in the real world, where d is the distance from the light source. Hence, point sources are easy to model, but they result in harsh and unrealistic rendering with very sharp drop in brightness and crisp shadows. This is unrealistic. In the real world, this doesn't happen like this because we have multiple light sources. Hence, we perform the attenuation in a quadratic way like this, using a quadratic term which is 1 divided by a plus bd plus cd square. So we have a linear term of d, we have a squared term of d, and we also have a fixed value of a constant value that we divide 1 by. The ABC values are user defined, so we can set the light attenuation to be harsh or slow. If we can set a and b is equal to 0 and c is equal to 1 to achieve this type of attenuation. Another type of light source is the directional light source or the distant light source. It illuminates objects with parallel rays of light. It is modeled with a direction d, notice the 0 here, and the intensity I with RGB components. Ambient light source models the same amount of light everywhere in the same. It does not have a position, it only has the intensity RGB values and will strike every point in the scene. Ambient light is used to model integration of multiple light sources and reflections from other objects in the scene.